Welcome to the EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at a subject, database management system. And for today's lecture, we will be looking at a relational model. The learning objectives for today's session include learning the terminologies of a relational model, the connection that exists between a mathematical relation and the relations in the relational model, and properties of database relations, meaning of entity integrity and referential integrity. If you could recall from the previous session, we have started with the data model representation and finally, we have ended with the architecture of a database management system. The architecture provided by ANSI-SPARC included 3 layers: external schema, conceptual schema and internal schema. This internal schema is otherwise called a physical schema, conceptual schema is otherwise called a logical schema, and the external schema is the user's perspective of a mini world. This 3-tiered schema architecture has several mappings among schema levels and are needed to transform requests and to transfer data. Programs refer to an external schema and are mapped by the database management system to the internal schema for execution. The differences between the 3 layers that we have seen in the ANSI-SPARC architecture are represented clearly here. When you look at the external schema, for a staff who is working for a particular department, it will be stored, the attributes of a student or staff relation will be stored like this: staff number, staff's first name, last name, age, salary. This will be a particular view, whereas another view to the same table is being referred as staff number, staff's last name and branch number. So, this is how people will initially perceive with different applications. And when it comes to conceptual schema level, the conceptual schema actually stores the schema of the entire table, which has the following list of attributes: say staff number, first name, last name, date of birth, salary, branch number. If you can recall from our previous sessions, instead of age as one of the attribute, this conceptual schema stores the value as date of birth. So, for a database to be more effective, it is not to be stored as age, the attribute is not to be stored as age, instead it should be stored as date of birth, from where age can be easily mapped. So, the conceptual schema really gives a clear understanding on the logical level from the physical aspects of it, but the external level might use only few of the attributes from the logical level, other view uses only 3 of the attributes from this particular logical level. Whereas, the same when it is represented at the internal level or the physical level, it will be like this format. The staff will be maintained as a structure, struct staff, and staff number along with its data type, branch number along with its data type, first name limited to a character size of 15, last name limited to a maximum of 15, date as date of birth format, salary in floating point values, and staff next, which is a pointer to the next staff record, and all these values will be indexed with staff number and branch number as its key values. So, this defines a clear index for the staff. So, when you look at the 3-tiered architecture with the previous one and the last current slide, this gives you a clear picture of the external view, conceptual view and the physical view of the system. To look at one of the major functionality of this database management system, it supports data independence. This data independence is in turn related to a logical and a physical data independence. Logical data independence means the capacity to change the conceptual schema without having to change the external schema and their application programs. So, anything that has a major change at the conceptual level without affecting at the external level. So, here we can note a point on age has been changed to date of birth. So, date of birth is the actual attribute that is getting stored at the conceptual level, whereas the external views are wanting as age. So, it can be converted and given. So, that is the actual representation, the capacity to change the conceptual schema without having to change the external schema and their corresponding application programs. Physical data independence, the capacity to change the internal schema without having to change the conceptual schema. If you majorly look at salary cannot be float at some point in time, but then that cannot affect the conceptual schema here. So, it is generally mentioned as salary, but here it has been defined at the internal level as float. It can even be an integer. So, to a rounded off value. So, this does not majorly change the conceptual schema level. So, all the attributes that are mapped at the conceptual schema are basically being present at the physical schema. So, any changes at the physical schema does not majorly change on the conceptual schema. So, that is a clear indication of data independence. So, when a schema at the lower level is changed, only the mappings between this schema and the higher level schema need to be changed in the database management system that fully supports data independence. The higher level schema themselves are unchanged. Hence, the application programs need not be changed since they refer to the external schema only. Coming specifically to relational models, some of the terminologies that are majorly used towards relational model include: a relation is a table with columns and rows. So, nowhere we will be calling it as columns and rows. From now on, for a relation we will be calling it as attributes and tuples. This applies only to logical structure of the database and it is not majorly to the physical structure of the database. Attribute is named as column of a relation, as I have already indicated. So, we will replace the word column with attribute from now on. When it is said as a table, table has got rows and columns, whereas when you say it as a relation, relation has got attributes and tuples. Domain is a set of allowable values for one or more attributes. Tuple is a row of a relation, as I have indicated. Degree is the number of attributes in a particular relation. Cardinality is the number of tuples in a relation. Relational database is a collection of normalized relations with distinct relation name. So far, whatever we have defined in the previous two slides, we have just given an indication of how those relational model terminologies would really mean. If you look at the first relation, previously it was perceived as tables. Now, with database management system we will call this as relations. This is a relation name that has been defined, say for with list of attributes like branch number, street, city and postal code. There is a common relation name called branch, which has attributes like branch number, street, city and postal code. And there are multiple relations which are included in it, multiple tuples. So, if every row that is presented in this table, if it is pronounced as relation, every tuple is supposed to be a relation. The list of attributes that are indicated mentions the degree, and the list of rows that are indicated or the list of tuples that are indicated mentions the cardinality of this particular relation. For a branch, there is a key attribute which uniquely defines this particular table. Without this key, it will be very difficult to understand all the other attributes. So, that attribute is mentioned as a primary key. And when I define another table like staff, which has a list of attributes like staff number, first name, last name, position, sex, date of birth, salary and branch number. With these list of attributes, again with a list of relations, there may be a possibility that this branch number may be part of this staff relation. This has to be correlated with the architecture that we have seen. There are two tables, staff table and branch table, and at the conceptual level we have stored these attributes, and at the physical level we have given the data type for these attributes. So, here we do not define one single table with all the list of attributes. Instead, we have created a table with the branch number alone, which in turn be referred. So, the primary key for this particular table is branch number, whereas the primary key for the staff table is staff number. And since the branch number is referred in this particular table, it can be very well called from the branch table, and now this key is to be referred as a foreign key. Examples of attribute domains. The attributes that we have referred in the previous table includes branch number, street, city, postal code, sex, date of birth, salary. The domain name for the corresponding table indicates branch numbers, street names, city name, postal code, sex, date of birth, salaries. The meaning of each attribute in this particular table: a set of all possible branch numbers can be listed as branch number, set of all street names in India can be mapped to street, set of all city names in India can be mapped to city, set of all postal codes in India can be mapped to post code, and the sex of a particular person will be represented in sex. Possible values of a staff's date of birth dates will be referred to as DOB in our database. Possible values of staff salaries will be referred as salary, and the domain definitions include: branch number basically has a string size of 4 and it can range from B001 to B999, which can be later referred to as an index. Street can be with a maximum size of 25 characters, city can be with the maximum character size of 15, postcode with a maximum number size of 6, sex with a maximum character size of 1, which can either represent M or F for male and female. Date of birth has a date with a range from 1st January and in a specific format like DD-MM-YY or DD-MM-YYYY. And salary, which has got a monetary value, it will be numeric again with some digits. So, as an alternate terminology, as I have already indicated, for a relational model, some formal terms need to be defined. The formal terms include a relation which alternates with table or a file, tuple which alternates previously called rows or records, attributes which alternates with column and field. So, whatever that we have been calling as table, now that we will be calling as a relation, or whatever we have been mentioning it as file, now we will be calling it as a relation. A row is replaced by tuple now, or a record is replaced by a tuple, column is replaced by attribute, or a field is replaced by an attribute. Now, we will look at some mathematical definition of relations, how it is being used. Initially, we will start looking at a Cartesian product, for which we may have to consider two different sets. Consider two sets D1 and D2, where D1 has elements like 2 and 4 and D2 has elements like 1, 3 and 5. So, when you do a Cartesian product, which is supposed to be an operation performed between two different sets, is a set of ordered pairs where first element is a member of D1 and the second element is a member of D2, which actually means D1 cross D2, which implies 2 will be mapped to 1, again 2 will be mapped to 3, again 2 will be mapped to 5. You will get 3 different set values 2 1, 2 3, 2 5. For the second value of the first element second element of the first member, that is 4, will be mapped to the first element of the second member, which is 4, 1, 4, 3 and 4, 5. So, this Cartesian product will multiply basically two different sets, but then arrive at a list of values. An alternative way is to find all combination of elements with the first from D1 and the second from D2. Any subset of Cartesian product is a relation. If you consider 2, 1 or 4, 1, this is part of the actual relation of a Cartesian product between two sets D1 cross D2, and this may specify which pairs are in relation using some condition for selection. For example, second element is 1 for both these relations, both these elements. So, if you look at this particular relation where the second element of this relation R is common, whereas the first relation if you look at it is 2 and 4, this can be represented as relation R is equal to x comma y, where x is an element of set D1, y is an element of set D2 and y is always 1. And this can alternatively be referred as, for a record S which has values x comma y, x is an element of set D1, y is an element of set D2, and looking at only this specific relation, x is twice y, it should be the other way, y is twice x. Consider 3 sets D1, D2, D3. If you are about to do the Cartesian product of these 3 sets D1, D2, D3, let us define an element of D1 as 1, 3, D2 as 2, 4, D3 as 5, 6. If we are about to do the Cartesian product between D1, D2 and D3, it will be like 1 will be mapped with 2 and with 5 of the other 2 sets, 1 mapped to 2 and 6 of the last set, 1 mapped to 4 and 5, 1 mapped to 4 and 6. So, that brings 4 elements, and 3 will be mapped to 2, 5, 3, 2, 6, 3, 4, 5 and 3, 4, 6. So, totally you will get 3 plus 3 plus 3 plus 3 6, 6 plus 2 8, 8 different elements for the Cartesian products that is performed between 3 different sets. So, any value that is a subset of these ordered triples is again a relation. So, we have started performing between 2 different sets. Now that we have done it for 3 different sets, now we will start defining the mathematical relation with n sets. So, Cartesian product of n set basically would be like D1, D2 up to n is usually be notated as D1, D2, D1 cross D2 cross Dn is equal to small d1, d2 up to dn, where d1 is an element of capital set d1, d2 is an element of set d2, likewise dn is an element of set dn, and is usually written in this format. And any set of n tuples from the Cartesian product is a relation of nth set. To further talk about database relations, we will initially talk about relational schema. Named relation defined by a set of attributes and domain name pairs are said to be relational schema. And set of relational schemas each with distinction name will be mentioned as relational database schema. So, some of the properties of this relations include relation name is distinct from other relation names. Relation name that we have considered so far are staff, student, course, branch. So, these are to be majorly distinct and should not be compared with any other thing. Each cell of a relation contains exactly one atomic value. Each attribute has a distinct name. Values of attributes are all from the same domain. each tuple is distinct. Every row that we have been representing in a table or every tuple that we have been representing in a relation is distinct. There are no duplicates that is allowed for a relation. Order of attributes has no significance. Order of tuples also has no significance theoretically. Now, we will define some list of keys. These list of keys are mentioned as relational keys. Initially, we will talk about super key. An attribute or a set of attributes that defines uniquely a tuple within a relation. For example, we have considered a relation branch which included only one key, that is branch number, with which you can uniquely identify all the other values from that particular relation. Then we called it as primary key. Now that we have a key called super key, either there can be only one value or a list of one or more values that uniquely identifies, then it becomes a super key. There is another key which is called candidate key, which is super key such that no proper subset is a super key within the relation. In each tuple of R, value of k uniquely identifies that particular tuple, that is, it maintains uniqueness. No proper subset of k has a uniqueness property, that is irreducibility. Looking at the primary key, candidate key selected to identify tuples uniquely within the relation is supposed to be a primary key. Alternate keys are candidate key that are not selected to be the primary key are supposed to be alternate key. Foreign key attributes or set of attributes within one relation that matches candidate key of possible relation becomes a candidate key. If you look at this particular relation, the primary key of this customer relation is supposed to be a customer ID, where with the forename or the surname will not be able to uniquely identify all the other values. So, we introduced a value called an attribute called customer ID that uniquely identifies this particular key, which is called a primary key. If you look at the list of constraints that a relation has to obey to look at a data model, null is one particular constraint. There should not be any value that should be left null in the primary key attribute. Say represents a value for an attribute that is currently unknown or not applicable for a tuple, deals with incomplete or exceptional data, represents the absence of a value or and is not the same as 0 or spaces which are values. The other integrity constraints that include entity integrity, referential integrity and some of the general constraints. Looking at entity integrity is nothing but a base relation where no attribute of a primary key can be null. We will just see an example of an entity integrity. If I am to define a team, there are a list of attributes like team ID and team name. Once when I have created this team ID, if I am supposed to delete T2, just this particular attribute alone, this particular value of this particular attribute alone T2, then all the subsequent values that appear with this particular relation has to be avoided. So, this cannot exist, that is called entity integrity. The second integrity constraint is integrity is nothing but the validity check performed on a database. The second integrity constraint is on the referential integrity, where if a foreign key exists in a relation, either a foreign key value must match a candidate key value of some tuple in its home relation, or a foreign key value must be wholly null. I repeat, if a foreign key exists in a relation, either foreign key value must match the candidate key value of some tuple in its home relation, or a foreign key value must be wholly null. If you look at this particular table where we have got artist ID, artist name mapped to artist ID, album ID and album name, where artist ID 1, 2, 3 is mapped to artist ID 3 is mapped to artist ID 3 on the other table, artist ID 1 and 2 does not exist in the second relation, but I have introduced another value called 4 which can be nowhere mapped. So, this link cannot be established and it is broken. So, that is called referential integrity, which may not be referred to any other specific table. The general constraints relating to this relational model include additional rules specified by the users or database administrators that define or constrain some aspects of the enterprise. Any additional rules on top of whatever we have looked at this kind of validity towards this relational model, we will add that also into the constraint list. Only when a database management system adheres to all these integrity constraints, or only when the data model obeys or this data structure obeys to all the constraints, this is called a perfect data model that is fitting to the database management system. So, we have seen two integrity constraints, one is a referential integrity and the entity integrity. In summary, for today's session we have looked at ANSI-SPARC architecture, where we have considered internal schema, conceptual schema and the external schema of a database management system. Then we have defined two data independence, physical independence and logical data independence, and we have defined on relational database terminologies, mathematical definitions to relations, where we have introduced Cartesian products from one set to multiple sets, and further we have defined relational keys like primary key, foreign key, super key, candidate key, and we have looked at several integrity constraints, entity integrity and referential integrity. Thank you.